Eh?
And if we just submit the different stuff, I feel a big deal.
All right, so we stop at, I think the next topic was supposed to be the assignment solution, right?
Yes.
So what was the assignment was this was the assignment.
Yes.
We are asked to read in serial data.csv. So let me start by reading the data. Read serial.csv data. I think we have the serial data in our data.
Solid.
Yeah, so just call it as DF, right? We are reading it as DF. Let me see how I read it.
That's mine, serial.
Okay, you read your own as serial.
Yeah.
Okay, so let me read mine as DF. Let me read it as DF. DF equals to PD. We have pandas already imported before.
Yes.
I think so, right?
Yes.
PD dot read underscore CSV. So let me quickly go and copy the parts. This is the data set. Copy parts. Then run it and see if I will get it just like this. I couldn't. I think I need to use the relative method by adding to dots. Yeah, so call the data by simply calling df. So this is the Siri data set. So that means the first question is sorted out, right?
Yeah.
The second part of the question says, prepare the data by dropping the name and manufacturer column. So if you go back to the data, we are to drop, we are dropping what? Name, series name, and what? Manufacturer column. You know the reason why we are dropping them? Because they are identifiers, yes. Right? Yes. And I told us that such a data set will not be good to be passed into analysis what? Model. And we are also trying to ensure that we only have what? All value in what? Numeric. Yes. That is the reason why we are dropping the manufacturer and the... Okay, so this is here we read it. So here I wanted to see the first 5. So this is where I am dropping it using a technique. So there's a technique I'm introducing here to drop as against the normal dropping that we know, right? You know, we did iLock and lock. You should remember. Yeah. So that method comes since the column. There's a reason why I am using this iLock, because the 2 columns I want to remove, they are serially arranged. There is no other one in between. They are following each other. Yeah. That is where you can use this method. Are you following? Yeah. Okay, so
the one we can use in the drop function.
Yeah.
If the
they are not in a serial exactly. But where you have 3 of them, you know, arranged serially, yes, you can just use this exactly. So that is the concept. So what is the question? Let me read it out so that I can write it in word. Question was drop what?
Dropping the name and manufacturer codes.
Okay, so dropping the name. I serial name, right?
Serial name.
And manufacturer, right?
Yes.
Manufacturer. Okay, I don't know if I'm correct with my manufacturer. Am I correct? Manufacturer.
Yes. Manufacturer code.
Column, right?
Yes.
Manufacturer column. Using, just to align the method I'm using what? iLog method. You understand? As a guest. So if you use the other one, you are still correct. So what matters is those two columns shouldn't be there before you start modeling it. So I will simply call the name of my data df dot ilog, because we know the syntax, ilog colon, the comma, then specify the range. Now we are deleting from 2. You know, in programming, this one is 0, right? This one is 1.
Yeah.
Right? That means what? We are extracting. We are leaving this and this behind by saying what? 2 and above. And what starts slicing from what? Column 2. You understand? So it's just a technique that we leave what? Any value or column in what? 0 index and 1 index. So we simply just say what? 2. I remember that we discussed something like this, where you specify the start point without the end point. It means you are saying that what? Start from 2 till the end. That is the meaning. Okay, so if I run this now, I think I should get data frame object has no attribute what? ilog. So my spelling is wrong. So I have it here as what? ilog. I think I'm correct now. Okay, so you can see that with that logic, I've been able to what? To cut away what? The first 2 columns, right? Good. So now I think the next thing for us to save it as let me follow my slide so that we can be on the same page. So now here I only wanted to display the first what? 5. That is why I added the what? Dot head, which is just to display dot what? Head. So I don't want to see everything. I just want to see the first 5. Okay?
Yeah.
Now, the next thing is alternative method. This is another method I also want to introduce. Another way you can select, you can use the column name to specify which of the value you want to extract. What I simply did here is I nested list inside what? List, and then call the names of the column. Do you understand what I did here? Is another logic which we can also use to select. Another data selection logic. That is what I'm trying to bring in here. You can see this is data set DF, right?
Yes.
Then I have the parent square bracket.
Yes.
And then I have the child square bracket holding all the headers. And because the headers are string, that's the reason why they are all what? Quoted. Okay, so if we want to replicate that, so like I said, an alternative way you can select specific column, right? Alternative method to select specific column. So what I will do, I will just say df square bracket inside. So I will just come here, go to the main data set. Look at what I'm doing. I will just take them like this. Is it the last one? Mineral and vitamin and mineral. The last one, right? So I can just copy like this.
Yeah.
Control C, and then come in here, then Control V. Then what I will do is that I will convert them to string. Calorie is different from, they are not together, have you?
They're different from code.
So use comma, to separate them. Protein, this gram, is it together with protein? Please, I don't want to go. Okay, then comma. This one fat.
Separate. Separate.
Okay. All right. Let me see. So the last one, they are together.
Yes.
So I need to put a comma here. Right. So you can see that has done that same thing you did with the what? The ILOG. So this is another method, another logic. Just mention the what? The name of the column and then make them string. That is all. It's clear now, right?
Yeah.
So now I go back to my slide. So the next thing now we need to save this particular outcome as what? Valid data set, right?
Yeah.
So that is the step now. We have to save it as data so that it will be different from the DF, because the DF will still be holding those identifiers. So the next step is for us to save. Now let's save the outcome as data objects. Data objects as data equals to. So I'll kindly take the whole of this, Control C, and then come in here, paste, right, accepted. I want to view it. I'll just call the name of the data. Perfect. So that is sorted out. So the next time is we want to answer the question now. Answering the question 3, which says what? What is question 3?
Fit a K-means clustering model with 2 clusters.
With 2 clusters, right?
Yes.
Okay, so let's go there. So this is part of what we have done before. So most of the code here, I don't think I need any too much explanation, right? Just like we are replicating what we have treated, but just to answer this question. So read the question again. Fit what?
Fit a K-means clustering model.
K-mean, sorry. Yes.
Yes.
K-mean clustering, I mean?
Yes.
Clustering model, I mean?
Yes.
Model, just that. That is it, I mean?
With 2 clusters.
Okay, with 2 clusters. Okay, so as usual, we have to import we say from what? From sklearn, right? Sklearn.
From sklearn. Okay. Well, it's already has been imported there.
Okay, you have it now. Let me continue.
I mean,
depending on when the light will come up.
Yeah, I'm saying that even in that,
we have it there already, have it? Okay, so we just go straight to the object now.
Yeah.
Since I've run the entire,
already important.
if I thought safe, I can just go and copy it instead of rewriting it.
Yeah.
Since it's on the same, but we have already imported it. So let me just continue. I believe the light will come up. So we just say we'll save it as object, right? As k-means 2, right?
Yes. K-means.
Then equals to the k-mean itself, following the case, and then so define the number of cluster to be 2 clusters. 2 clusters, then equals to say 2. the comma, number of units, underscore units, also, right?
Yes.
Auto. Then to avoid changing value each time, put a random, face it as 42. Random underscore state. Then 40 what? 42. Right? Now we transform the data using the objects we just created as came in. Came in 2 dot fits, and then we are transforming data, right?
Yes.
All right. You say came into is not defined. Did I make mistake in my one?
Okay, you K means
Instead
KM
of
instead of M.
yeah.
The first one, look at it. Start from the beginning. KM, not KN.
Oh, sorry. Let me just aside this one. Uh-huh.
The second one.
The second one. The first one is correct, I mean.
The first one. Second K means you put KN instead of AM. No, not that one. Lower. Go down.
Oh, thank you very much. Okay, man. Okay, so remember what I told us last time, that this we calculate the what? The average of the values under what? The column. Right? So the next thing is we're already modeling the data. The next thing is converting the cluster data into what? Data frame, so that we can substitute the headers. All right? Because if we try displaying the center now, for example, now, or was it the place I am? Okay, this is one I did last now. Because when you output it, what you are getting is what is framing the data, but is using is generating its own column name using numbers. So let's quickly apply this, which is a converting, right? Converting, let me use comment, converting the clustered data into data frame, So to do that, we are to import Seaborn. We say import Seaborn. Are you see following? As what? SN. So I will do PD dot data frame following the case. Then supply the objects. Our keyword came in. K means what? 2, right? Dot the attribute, which is what? Cluster underscore what? Centers. Centers underscore. So if I run this is going to output the data frame. Now, the next thing is for us to add the column what? Name, as in the original column name from the data set we are working on, before we can, think of plotting it in a heat map. Are you getting it?
Yeah.
So the only thing we are adding is just column equals to data.column in order to substitute those numbers with what? The right column. Okay. Okay, so just add this. That's column equals to data dot columns. So like I said, to add the original headers, I'll just copy this same code. Or I can just even put it here at once, comma, say column equals to data, right? Data dot column. Data dot column. So if I run it, I have the headers substituted.
Yeah.
So the next thing we have is to convert it to what? To now let's put the data in heat map, right? So that we can write our observation. I believe what I'm saying align with your,
yes.
So I can continue.
Yeah.
Okay, so to put the data in bitmap, in heat map rather, now let's put the data into heat map. Heat map. So SN dot, remember that was why we imported that symbol, heat map, because that is the library we are using to plot this graph. Then PD, but everything we wrote that.
You didn't save it in the graph.
No, I just want to copy it. Eh?
So I saved mine in data.
Okay,
in an
okay.
object,
So you just supply it as well.
called it.
Okay, so let me send it. And then so you have the heat map. Now remember I said just to remove the axis, just put comma, just put semicolon here. Run it again. That will arrange it very well. So we have just cluster 0 and 1, right? Is that what you have?
Yes. It was 0 and 1.
0 and 1, right?
Yes.
Okay. Now, for us to add for us to display the, okay, I've done that. So for us to add, I've done this also. Now, for us to redefine the color, right?
Yeah.
We add another attribute called, what's the name of the attribute? CMAP, right? CMAP equals to just to update the color. So we just update it here, comma, right?
Yes.
Comma, CMAP. CMAP equals to what? Capital arrow, D, E, U. So, any mistake? CMAP, arrow, DB. What did it say? Unexpected. What? Unexpected. Oh, we are supposed to bring it This is not where it should be. It should come after this one. You understand? That is the reason why syntax I have to comma there. All right, so I have the graph. So now the next step is let me see. Now we need to also add the values on the boxes or the section, right? Yeah. Just to update a not, right? Yeah. Equals to what? True. Just to achieve that, we just come back here, put comma, and say what? A not equals to what? True. It's a Boolean value. That's why we are not quoting it. Okay, you write it, and that will enable us to view the values on the boxes. So let's see your final interpretation. Does it align with low in what? Vitamin mineral, serine for kids. That's clustered 1, high in calories and vitamin minerals. Series for what? So we are recommending this now. Series for what? Adults. Why this one is for what? For kids, based on the performance. Is that what you have? What was your conclusion?
Actually, my recommendation was the thing about what I did, the thing of the adult.
Okay, but it aligned the other side.
Yes.
Sure. All right, so now let's add a new topic. It is called inertia. Inertia. So this is another topic that is also very important to know.
My copy on that.
Which one? This one, right?
Yes.
Producing a new topic, though it's still part of the clustering method. Before we bring in, remember that I did mention that there are three method of what? Data modeling, right? Either clustering, which other one again? Hierarchical and what? DB scan, right? So this one we finalize the aspect of that clustering. So it is also used to know, to measure and to calculate whether to use 2 clustered or to use what? 3 clustered. So this is just like a factor that helps us to know whether, because you will have asked that, how do I know whether if I'm given a data set, I should do 2 or 3 clustered? So the inertia point is what we determine. So let's look at what is inertia. I think I need to zoom it so that you can see it better for now. See, let's start switching to. All right, so what is inertia? So like I explained here, how do we know what is the right number of what? Clusters. So the whole essence of this topic is to guide us in choosing the number of what? Clusters we want to have in our data. So why there is no right or wrong number of clusters? So if you do your own and say 3, there's no law that compel you that you are not doing the right thing. So everything depends on what you want to achieve. I said, why there is no right or wrong number of clusters, you can use the inertia, aka within cluster sum of squares of WCSS to help inform your decision. So like I said before, the whole of this is still under clustering, data clustering, but we are looking at, okay, what should guide, what factors should determine whether I'm to choose 2 clusters or 3 clusters. So that is where we are bringing the point of inertia. So this square this distance and sum them to calculate inertia for the 2 clusters. So this is going to be squaring the value and be adding their results. So that is the basics or the principle that it uses to know at which point. Now, this diagram will not teach us better. So you can see the graph of inertia as against what? Number of what? Cluster. So if you look at the graph very well, how do we know? If you look at the graph, I have rerun the model, right? With additional what? Cluster. And plot the inertia for each what? Value of K. Remember that K is what? Number of clusters, right? So what the idea, the picture, what we are trying to unravel here is, we look at the data now from the point 1, that from the top, there is able. We usually take note of where the able, where is curving. So we can use that to determine our what? Cluster. So you can see that from the first one to the second one, we can say where that first arrow is, at which I can navigate. Where the first arrow is, yes, from the top, where the first arrow is, that is where it intends to curve. So that is just like another able. So we can count that one as what? From the first one to that place as what? One what? Cluster. Then if you go down, you see that what? You keep having the able. Yes. The line is not straight. You keep having what? The able. So that's what we are trying to illustrate here. So once you run this code, you run this inertia will inform you as regard to the number of ables you have that will determine the number of what? Clusters. Are you following? That is just the concept. Can I move to the next slide? Yeah. Now here, I try to point out a point here that was log forward able. So now you can see that what? In this case now, I'm trying to have what? Just 2 clusters. And what is informing me here is, here, if you look at this here, log forward able or inflection point, right? Where adding number clustered has a relatively small impact on inertia. In this case, where K is equal to what? 5. That is, in this case, you are saying that what you want to K here, your number of cluster, if you count from 2. Remember, after that, we cannot have 1. Cluster start from 2. Yeah. That is why if you look at the S-axis of the graph, we do not have 1. Instead, there was what? 2, 3, 4. So I can say, okay, I want to have 5 what? Cluster. So now this is the code that we generated. So I want you to write the whole of this code because we are going to code them. So I have mine already. So I don't have to, I will still also code alongside with you. But once you finish writing, then I can explain it, then we can go for implementation. By view of the code we are going to go through for us to be able to get the inertia. So let's start taking it one after the other. So I will see how we are arriving at that code. Is it the entire code you have written before? Oh. So let's start exploring the inertial value. Need to switch from here. Now, let us start exploring inertial value. So the first thing is to call the object that is KMA2 dot inertia underscore. So you can see, did you get this value like this? So that is the inertia. Remember that that the inertia is used to, now that is for 2. So if I do K mean 3, so I'm trying to analyze the number of clusters we can possibly have. So if I do K mean 3 dots inertia also underscore. So I have a different value. Now, the next thing is for us to create inertia plots. Inertia plots. So our objective, are you following? Our objective here is to know how many clustered we can actually get from that data set. So from here, we are looking at 2 to 15. 2 to 15. You know, if it is 2 to 15, definitely it will be what? 2 to 16. You understand? We are to follow normal counting.
Yeah.
Good. So now let's exploit this option. So our goal is what? We want to create 16 cluster from this particular data set. So let me start by exploring for the two for the 2 clustered, and what we are exploring is for 2 clustered and the 3 cluster, which I ran their inertia here now. So let me do for K mean, for K mean 2. I'll do K mean 2 equals to K mean K means the number of clustered we want to get within this.
Which data set are we making use of?
That same data set, that same one. The continuation of that cluster, yeah, that assignment, exactly.
Okay, the assignment.
Yes. Yes, we are still on the assignment. The whole of this is still under cluster. We are just trying to know how we can decide on how many clusters we want to generate. That is what brought about the inertia. So
I thought about the
no.
data set of books, TV shows, and behavior.
No.
Okay.
It needs
Yes.
how to run states the objects came in to dot fits, want to transform same data, then followed by its inertia that we just confirmed the other time. So came in to dot inertia underscore. So if I run this, So I get k-mean object has no attribute inertia, so it's present error. Okay, so I have
K-means 2 in this assignment, right? Giving me some around your
from my own,
yes.
and we did the same thing.
Yeah. But when I run it in the class what we were doing things, it gave me the same figure as the when I did the assignment in another notes
Another notebook.
here,
Okay.
I was under the same, not under the password.
But the one I'm doing now is the assignment to this one. So let me just conclude this and see how it goes. Now,
I think the figure is giving me.
yes, and this is the figure I'm getting now for the two clusters. Now, what I want to do now is I want to use the loop because since it's beyond 2, we are having between 2 to 16.
Yeah.
I need to bring in Python for loop. That's why in that code that you wrote, there is a for loop. So that for loop is what we iterate across multiple instead of us doing it one. So I would say using for loop concepts, I would say my k is stored. Remember that in this case, just for you to understand, k is going to be equals to, say explaining, so that you can interpret the value in my for loop. So my k will represent numbers of cluster, which we have already established before now, right? So in my for loop, 2 will represent clustering. 2 will represent clustering, starting, and that is what it has been. Starting, right? Because I said we cannot have 1, right?
Yeah.
Starting with 2. Now, if I'm to write the for loop function, I will say for k. Now that you know the value of k is the number, right? For number of what? Cluster. That's what you are saying now. For k in range. For k in range. So range is a function because we is iterating across different what? Value. For k in range, we specify the range that it should start from what? 2 to what? 2, 16. You understand?
Yeah.
2, 16. Then the center of for loop is you put colon like this. Then you go to the next line. Now, this indentation matter. If this cursor comes to where you have 4, it will not run. When we're learning Python, I said Python prioritize what? Indentation. Once you miss the code alignment, it will not execute. Are you following?
Yeah.
Okay, so once you put it here, press enter, it has already what? Indented. Now, we will now create our object. So k-mean, the first one is k-mean. K-mean, so I'll say equals to, then I'm using the same function, means, just like the way we did it. So don't want to be doing it for 1, 1, 1, 1. That's why we are bringing 4, so that it can loop across, iterate across all the what? The clusters. So now here, n equals to clusters, you will now say equals to k. See the logic now. When we're doing it individually, we're putting equals to 2. Good. Now is the one that will factor it out since we have defined the range between 2 and 16. So at the end of the day, it's the one that will tell us how many clusters do we have there. Now, comma, then we are still repeating this attribute, which is init auto, right? Auto, then comma, the random underscore states.
We were in it in the earlier code in PowerPoint. value of 10.
You said?
You give the n underscore image the value of 10.
Okay. Is it?
And the what you have in the PowerPoint. The code you have.
Okay, that should be. Are you sure? Okay, let me see.
Random stage give the value of 30.
30.
Yes.
Okay, now let me just go there and confirm what you are saying. What you are saying here, right? This is what you are talking about. Is it the code you are referring to?
Yeah.
4. Okay, here. Yeah, 30 and what?
10.
10. Okay, so but here now, what am I coding?
Give it auto.
Auto what?
Auto for the image. For the image.
Instead of 10, have you?
Yes.
Okay, okay. Let me just say it will still work, but here I give 30, have you?
Yes.
Here I give 30. Okay, now let's transform the data. That is a K mean 2. Sorry, K means we are not putting K mean equals to, sorry, dot fits. And then the data we are working with is what? Data.
Yes.
Then let's also calculate the inertia. K means dot inertia underscore. So if I run this, see what I have, error. So what is it saying? That what the n parameter k-mean must be a string among what? Auto. So that means you have to correct the one there.
Okay.
Okay, so these errors are much. So let's see what's.
Okay, you go there on it does the one in front really well.
Yes, I want to. Yeah, I think so. Yeah. Okay. So have you executed to this place?
No,
Okay. So well, you have your code, have you? Okay. Let me just hold on for some second. Then you replicate it. I think I've applied here, right?
yeah.
So apply here. We applied here.
Yeah.
So now we want to print. So just write down this. When we ran the code, we didn't get the output, but the calculation has been done. So here we want to print it using a Python printing function. So using Python method to print the inertial values. So the only line that I will update is the last line. I will add the last line to the code I have executed. You understand?
Okay.
Which means that I am outputting the value.
Okay.
So yeah, that is the only thing we are adding. So like here now, we just come here, say to print the inertia values.
Will you still be in line with the indent or will you move?
Which of the?
It's still in line with the indent.
Yes, if it does not in line, there's a way we are going to make it to align with the index. Using a print function. So I will just say print, and then take the whole of this inside as the parameter. Let me complete the print function. If I run it, I'm expected to get the values. I know these errors that what did they printed out now? Check your own and see. Let me see. Yeah, I think we are correct. So we are supposed to get all the values printed out, the values of iteration. But if we count now, we're supposed to have up to 16.
Came up with
The same thing with your own.
came up just a figure here at one.
Just a figure as against the listing. Let me see if let's rerun the entire cells again and see if something is. Warning doesn't mean that. Let me even try and debug what the error is. Version of the. This is it now.
Yeah.
What value do you, the value does it align? Just check the number.
The first value I got is tallies with yours, all the way to
down to
4434.
Yeah, that is what I have here. So yeah, that means you are correct. Now, if you check here now, so we are going to add it together. We are going to add this value that we generated with the k means what? You know, the values we got now is we are using append. So we have inertia underscore values dot append. Then we are supplying the k means dot inertia. So here we are appending to display the inertia value. Do you understand it? Or let me say, this is where we printed this particular one, right? Now here, we want to join them together using append function. Because where we are going is that is where we'll be able to pass, we'll be able to see it as object that we can apply that heat map on. So let's take a note of this one. Using append to display the inertial value. Using append to display the inertial value. To display the inertial value. So the only thing we are updating here, let me use comment, using append function.
Okay, see now it broke your value. See where the remaining came out. I said, see where the remaining values came out. So,
okay, all they are together, Abi?
Together, yeah.
Okay. Append to display the inertia values. So what I'm adding is just let me update it here to avoid the.
I wanted to ask, won't it be in line with the index before it runs something else?
In line with the index.
The index, you know, like the print now, when we shifted it that way, it gave just a single value. We run it the same tool with the append. We give a single value.
Let's see what we have from now. Down. So here I'm removing the print now. You understand? I'm removing the prints. I'm removing the prints now. So that was just it. Now I will just say inertia underscore values dot append. Then I'm joining this with the k-mean object that we created, which is k-means dot inertia underscore. So if I run this, it's complaining that inertia value does not what? Is that the same? You have the same thing,
Yeah.
Okay, so let's check inertia value, or do I skip any?
Okay,
this is
the natural value was not
anywhere,
No.
Oh, yeah, look at it here. We left it.
Okay.
We are supposed to have created it, but without giving it value.
Okay.
So now let's go back to our code here. You understand? Yes. Just like you created a dictionary. So we are passing the value in now. So the dictionary is just inertia underscore value equals to empty dictionary. So I will just say inertia underscore what? Values equals to empty. So if you run it now, let's see, we're going to get something good. Yeah, it should be there, but you just want to call. If you want to know whether it's there, we'll just call only this. That is what I did here. Now look at it. So after running it, you want to know whether the values are there. You run just what? Inertia. To know whether the values have been substituted. Because when we declared it here, we declared it as an empty list. So now let's try and see if it exists. So I will just simply copy this. Control C. Brought that value, right?
Yes.
So let me see mine. All this error. Good. So I have this to confirm that what the values have been sent to the empty list. Okay, so now the next thing we want to look at is this. So this is where now we want to turn it into what? Data, so that we can plot a line graph. Sorry. This value now, we want to plot it, but we have to save them as series. You understand?
Okay.
You know, as they are raw like this, that time, like this, we cannot put them in a graph. Yeah. So we have to recognize them as series and objects, you understand, before we can substitute, before we can use them to plot the graph. So the first thing is to import matplotlib dots. I don't know if we have imported that line before. Are you sure we have it? If we don't have it, we have to re-acknowledge it. Do we have it? I think we should have it now. We should have it from the beginning.
Yes.
We have it, have we? Okay, since we have it, so but just to acknowledge this for those that will be going through the video, I do not know when we did that. So let's quickly import it. So import matplotlib dot py plots as what? PLT. As PLT. Now we'll now say PD dot series. Remember that the series, the S is usually in capital letter. Now we pass in that inertia value, which is inertia underscore values in, just to make it an object. So if I run it, it's now an object. Is it the same thing you got?
Yes.
Okay, so now to align the index, I think this is where you were talking about. To align the index, I know you are talking about index. To align the index with k-means number. the numbering here, because what we generated now, if you look at it, this number does not align with k-mean, right? Because our k-mean started from what? 2, right?
Yeah.
So to align it with the k-mean, we have to add what? Index equals to what? Range. Then we'll specify the range of our k-mean so that everything will fall in that order. So let's update that.
To align index with k-mean.
Yes, to align index with k-mean. So here, to align index with k-mean. So we'll simply update here, just come here, and then comma, the index equals to range 2, comma, 16. That was initial range. So if we run it now, we should be able to have the index arranged. Good. So you can see it now. Starts from the k-mean range.
Yeah.
Right?
Yeah.
Okay. So the next thing is, now this is where we are going. We just want us to finish so that the next class we're going to take the standardization and what is it called? Which other one is remaining? DB scan and the hierarchical. Good. Finish everything. So now we have to save it, save that initial series and plot graph. So first we save it as what? The whole of that code, we save it as inertia underscore series, and then we'll now use it to plot the graph. That is the next step. That is going to be the last step for this section. So now, save series and plot and plot. Like I said, we just take the whole of this. I will just say inertia underscore what? Series equals to, right? Save. So now, if now I have recognized it as an object, so I can plot it. So to plot it, I'll simply do that inertia underscore series, inertia underscore series dot plot, and then so I have the graph. So you can see that original picture that we have. That is what we are gradually what arriving at. Good. Now, you know why we are having this as S, have we? This as we just add this, right?
Yes.
In order to eliminate it. Okay. So now let's add marker. You can see that what all these dots. We don't have dot to enable us to know the able.
Yes.
Right? So we need to add the marker using this marker equals to 0. Marker equals to 0. That is the only attribute we are going to add. So now let's add marker. To add marker, markers, we will just update this particular inside this. We'll say what? Marker, right? Marker equals to 0. So if I run it, I hope that should So I have an error. Let me debug. What do I have? What is the error? Marker. I don't want to sell error here. Let's see. Unrecognized marker style 0. Okay, so I think I use number instead of O. Yes. Yes. So let's do that. Where is it here? I use number instead of O. Yeah, you understand. So
Small letter O.
yes, one letter O. So you can see I have the marker because the marker is what will help us to know the able. So you can see this was exactly what we got that time. You can see this able here from the graph I showed us before we started plotting.
Yeah.
Okay. So any question?
So far, so good.
So we can do for K-mean for 5 clusters. The only thing is that those places where you put K-mean 2, change it to 5, 5, 5, 5, 5. But at least this is we have been able to use our inertia to guess or to know the number of clusters we can have, taking note of the able. So you can see that if you trace it now, here it can be one cluster, right?
Yeah.
Then when you go down, I can say this is another cluster. So where you have the able, you can choose. So remember, I started by saying there is no standard number of what? Cluster. No one is right, no one is what? Is wrong. So the whole idea of the inertia is for us to know, okay, let's just know how we can arrive at whether we are using 2 clusters or what 3 clusters. If not, we have ended clustering, that's modeling. So the next class will focus on the hierarchical and DB scan. These are the 3 common data modeling techniques. Any question?
So if this particular graph now is to guide, if for example, like it's to guide me, I can say I can pick out actually about 3 to 4.
Yes, good. That is exactly what we are, because you can see the number of ables are much.
The number of elbows are much.
They are much.
Because, for example, this one here, this one is quite close.
Close, good, exactly.
So I can call it
one cluster.
And the next cluster is here.
Here, good.
This one is a bit close, but there's a deflection.
Deflection, here.
And then down here.
Down here, good. So that is the whole idea of the inertial concept.